Alright, so in this video I want to talk about an alternative way to label the points in R2, so in the plane. Okay, so the traditional way of doing this, which we've been using throughout this course and you've been using for a long time, is to say, well, you have an XY axis, and then if you take a point there and it has coordinates XY, meaning if you drop a line from this point perpendicular to the x-axis, then it will intersect the x-axis at a distance x. And if you do the same for the y-axis, then it will intersect the y-axis at a distance y. Now, this is a very convenient way of labeling the points, but in some situations it can become cumbersome. Okay. So let's try and figure out a different way. So suppose that you know the distance r between your point and the origin. Okay. So if you know the distance, then you know that this point lies on a circle with center at the origin and radius r. Okay. And now if you also know the angle that this radius makes with a positive x-axis, let's call it theta, then you know exactly where this point lies, right? Because r tells you, well, I'm going out a distance r from the origin, and then theta tells me I'm going to rotate in the anti-clockwise direction through an angle theta, right? And then that point is fixed, it can't move, right? And r theta, those two numbers are called the polar coordinates of the point. Right. X, Y, the ones you've been working with for such a long time, right, those we call the Cartesian coordinates. Right. Now, how do these different coordinates relate to each other? Well, if you calculate, say, cos of this angle, right, then we're sitting here in a right triangle, and the cosine of an angle is always the adjacent side of the triangle over the hypotenuse. So x over r. So that tells us that x is r cos theta. Okay? And if you do the same thing with sine theta, then sine is opposite over hypotenuse. So y over r, so you get y is r sine theta. Right, so those are the two basic formulas that tell you how the Cartesian and the polar coordinates relate to each other. Right. There's a couple of other useful formulas. For instance, we can get tan theta, right, which would be sine theta over cos theta. Right. So we can multiply top and bottom with r. So we get r sine theta over r cos theta. So that gives us y over x. Right. And the last very important formula, well, what's x squared plus y squared? Well, here we have a right triangle. We're squaring this side, and we're squaring that side, and we're adding the two together. Right, so that should give us the square of the hypotenuse by Pythagoras' theorem. So that's r squared. Okay. So let's put that, write the tan theta over there. Okay. So there we have the four very important equations that tell us how to move between polar coordinates and Cartesian coordinates. Right. These are all you need. Right. You can do all the problems with these four equations. Alright. So now let's look at an example of writing a point in polar coordinates. So let's say we have the point xy is, say, minus 1, 1. Right, and we want to find its polar coordinates. Right. So, what do we do? Well, you can use this formula to calculate r. Right? Remember, r squared is x squared plus y squared. So for our point, xy is minus 1, 1. That gives you 1 plus 1, which is 2. So we see r is root 2. Right. So now we only have to calculate theta. Right, so I like using this formula for tan theta. Right, so we see that tan theta is y over x. So in that case it gives us tan theta is minus 1. Okay. So now, if you calculate theta, it gives you, right, of tan 1, sorry, minus 1, which is minus pi over 4. Okay. Now is that the right angle? Well, not exactly, well, not necessarily. Right, because remember, tan theta is period 2 pi. Right, so what that means is that tan theta, if you add any multiple of pi, right, so if you add pi or 2 pi or 3 pi or minus 5 pi, right, you still get the same value. Right. So applying this identity to what we've done here, we see that actually theta has to be minus pi over 4 plus k pi, and for some k. And this k is of course an integer. So now which value of k do you have to take? Well, let's draw the sketch. xy. Right, so remember, when you're here on the positive x-axis, that's theta equals 0. Right? If you go to the positive y-axis, then you've moved through pi over 2 radians. So here we have theta is pi over 2, and the negative x-axis where theta equals minus pi, pi. And here we have theta is 3 pi over 2. Okay. Now where does our point sit? Our point sits over there, right? At x equals minus 1, y equals 1. Okay. And the angle we found here was minus pi over 4. So we need to get there. Okay. So getting from minus pi over 4 to there, okay, we have to add pi. Okay. So that tells us that our theta is in fact pi minus pi over 4, or then 3 pi over 4. Okay, so the polar coordinates r theta for this point r is root 2, theta is 3 pi over 2. Right. So that you could actually get different values here. Right. So you could add another 2 pi to theta, and you'll still get the same point with a different value of theta. Right. And there we go. Right. Polar coordinates for a point.